Okay, so hello folks, and welcome to another episode of EMF Informer. This is me, Seth, and I'm with Geoff.
Hiya, Seth.
Good to see you, Geoff. Right, so the topic today then is mobile phone masts, or cell phone masts, cell masts, whatever you want to call them. Do we have some questions to discuss today then?
Yes, I think we do, Seth. This has caused quite a bit of an interest, and the big one for me is this white zone kind of desirability. And I think you had a slide there, which was from Wales, I believe, which showed what basically is a white zone. And I think you had a map that's the one, Seth. If you look on that map, the question I've had from the video is really anyone who's looking to be away from a mobile signal, just to make it clear to folks, really they need to look for an area which is in the white shade. Would that be right? We call it a white zone, I think. So would that be right, Seth?
Yes, when especially when I make these coverage maps, the white areas here are usually valleys, often quite steep valleys with ridges, hills around, and these can be dead zones where there's just no signal. So yeah, people who are looking for a strong phone signal want to be up on the plateau or on the big flat areas and not in the steep valleys where there is very little signal.
Is that what creates the actual white zone or low signal, Seth? Is it the topography of the landscape, like mountains and valleys, where the signals don't penetrate so far? Is that what creates the white zone?
Yes, that is true. At the moment, there are a lot of mobile phone masts around the country, but it's just not cost effective for the operators to install masts that can get into every steep little valley, especially when there's very little population density. So generally, especially if it's an ES person, they would be looking for these valleys where the mobile phone antennas simply don't have an angle to get down into those valleys, because they have quite narrow beams, about 15 degrees in the elevation. So it's just not possible for them to get down into the steep valleys.
Yeah, and that leads on to the next question, Seth, is if, for example, you have a mobile phone and you are in one of those white zones, does that mean that your mobile phone is going to try and compensate for the lack of signal? Is it going to increase in power to pick up a signal?
Yes, and this is a very key point for people, on the one hand, who are trying to save the battery on their phone, because if you're in a low coverage area of 1 bar or 2 bars, your battery will drain faster because the phone needs a lot more power to actually connect with the cell towers. On the flip side, people who are trying to avoid mobile phones, who might be electro hypersensitive, it can actually be worse if there's a mobile phone nearby which is struggling to get a good signal to the tower. That handset will actually be transmitting at 3 or 4 times more power than it would be in a good signal area. So conversely, people don't realize phones can actually be giving out more EMF when they're in a low coverage area.
Yeah, so I guess that sums it up. But the next question is, Seth, is about you've got a slide there which shows a kind of a rural area. What happens in a city area? Are you getting much more coverage and less white zones?
Yeah, I mean, in the cities, there's very good coverage pretty much everywhere. There's a lot more mobile phone masts, and there generally tends to be less steep mountainsides and so forth. So people who want a good coverage, the city is always going to be the place to be. However, I've had actually one person this week asking me, Geoff, about what kind of advice we would give to someone who was looking for a place to live which actually has zero coverage by mobile phone masts, because this person's quite electrosensitive. And generally, a lot of people do seem to be keen to live further away from masts because of the strong signal power at close proximity. What advice could we give them?
Well, I guess really, Seth, I mean, measurements are key. And if you're trying to find a place with no signal, obviously it's good to get an EMF surveyor involved and do some professional measurements. Obviously, there's some rules of thumb. The further you go away from the city, the more likely you are to find such a zone. And you need to look for those valleys or shadows, as we call them.
So one question I do have there. What do you think, is it actually better to choose a place where there's really no coverage at all? Or is it better to choose somewhere where there's a little bit of coverage because of the prospect of new masts and new antennas actually being built?
Yeah, I mean, that's a good point, because we have quite a number of clients that have called us, and the reason they contact us, because we're shielding specialists, because they've actually gone to the trouble of finding a place that has zero mobile signal, and then 18 months later along comes the mobile company at the request of the neighbors, yeah, and says, we've been asked to provide a coverage in this area because people don't get a mobile phone signal. I know many people that prefer to say, well, okay, I'm going to get an area with a small signal, so that nobody's going to come along and put a mobile phone mast there. And again, you know, if you want to do that, get in touch with a surveyor such as yourself or whoever, and get a proper survey done so that you know what you're dealing with. And that leads on to another question, Seth, about the times of day, because I know people that have had surveys done, EMF surveys, and depending on the time of day when the surveyor goes, there's different levels of signals. What's your thoughts on that?
And it really comes down to what it is you're wanting to measure. What is your goal? What is your criteria? Because if we actually look at the peak power output values of the antennas as picked up with a meter or a spectrum analyzer over a period of time, then the peaks are actually going to be the same, whether it's nighttime or daytime. It's generally going to be the same. It could be 50 millivolts per meter, or 150, or even 250 if you're close to the mast, at night and in the day. However, if you're someone who's really interested to know what the overall exposure is, as in the dosage that someone would be receiving, so this is particularly for electrosensitive people, they might be interested in knowing what the average dosage is over an hour, for example. And in this case, you would find that it would be much higher during the day, during peak busy times, than at night when there's not many people using the phone, because the mobile phone masts will only transmit, and will transmit at the lowest power they can to meet the traffic requirements, the data traffic. So nighttime is going to be a time where there's a lot less traffic and a lot less dosage, but the peak levels could be exactly the same.
Yeah. Another question now, Seth, is with regard to cities and rural areas. Generally speaking, because you have more mass in cities, the actual power levels would be lower in a city in comparison to if you were near a mast in a rural area. Would that be fair comment?
It's that's a difficult one to answer, because the masts in cities tend to be microcells, which are smaller. They're not as high. They're often a single pole, looks a bit like a grey telegraph pole, which is transmitting in 360 degrees all around. So they don't go very far, but they have a very wide area of coverage and a high elevation angle of, it could be 30 degrees. Compare that with a rural mast, which is usually on top of a kind of steep hill, a much higher mast that the antennas are on, and the elevation angle of the actual signal beam might only be 10 degrees. So there's a chance that if you lived, for example, in a house in the lee of the hill under this mast, and the signal is really going over the top of your head. So it depends where you are. So this is where you would need a surveyor, or you would need a meter and the equipment to actually test for that. But the city masts are going to be lower transmit power, but there's more chance that they're going to be much closer to you. So it's kind of swings and roundabouts there. I was also thinking, well, people are going to ask now, if I am living close to one of these masts and it is transmitting at quite a high power, rather than moving house, is there some mitigation we can recommend to them? I mean, how effective are various shielding materials that one can buy online? How might these compare to the stone walls of a house or wooden doors, etc.? Can you comment on this?
Yeah, I mean, the materials used in houses, they do provide some kind of level of shielding. Modern houses, sadly, are not that good. For instance, your average 3-bedroom semi-door is probably going to shield somewhere between 5 and 10 dB. If you live in a medieval castle where they've used an old door that's half a meter thick, you might get 20 or 30 dB. But there will be some level of radiation taken out by the materials, but they do vary. Generally speaking, unless you've got like six feet thick granite walls, then and you are near a mast, you will need some shielding. And the materials that are out there that you can buy online, providing they've been tested at a reputable facility to international standards, they can provide 40, 50, up to maybe 80 or 90 dB, depending on the materials and the application. And they can really stop the signals from coming into your house. So that, pick one of the shielding materials that are out there, contact a shielding specialist, and work with a surveyor as well, because when you've installed shielding materials, you need to check that you've got everything shielding. For instance, if you leave a window unshielded, then that's really going to leak radiation. So shielding is very effective, and it's another alternative to moving house.
Yeah, sure. So you did mention 40, 50 dBs or higher for these shielding kind of nets or curtains that people buy to put over windows and doors, which are the weak points where a lot of signal comes into the house. And if somebody's electrosensitive, walls provide quite a good protection, could be 15 dBs, but the windows and the doors are the weak points. So these shielding that people buy, when you say it's 50 dB, for example, can you explain that in a kind of simple way for the layman?
Terms. Yeah, of course, we kind of get technical, don't we, Seth? You're talking about 99.999% of that shielding is there. So it's only letting 0.001% of that radiation through. So it's really it really is making a big difference. I know somebody that saw your original presentation was asking about, you mentioned home devices. So people may shield a mobile phone mast, or they may not have a mobile phone mast signal, and therefore they think they don't have a problem. Yet what they do is they wheel in the Trojan horse in terms of a super strength Wi-Fi hub. I mean, have you got any comment on that?
Yeah, I mean, it is all comparative, as we showed in our previous video, inside the home, typical devices, appliances, which are close to people, for example, 4 meters away or 6 meters away, the proximity is simply going to mean that you're receiving a higher dosage of electromagnetic radiation than something which is a mile away, such as a mast. So typically, yeah, your laptop, your Wi-Fi, your phone, your smart TV, you know, you're looking at 300, 500, maybe 800 millivolts per meter from these things in the home. Compare that to the mast, which is a mile away and having to get through your brick walls, where it's losing 10 to 15 dB, which is, you know, I mean, 10 to 15 dB, that's 90% of the signal strength is lost just trying to get through the wall. Whereas your Wi-Fi router doesn't have that problem, because even if there are walls inside the house, they're only made of very thin plasterboard, which doesn't really attenuate the signal much at all. So people do need to realize that if you're someone who really wants a strong signal, then yes, get the devices close to you, you know, make sure there isn't walls in the way. And on the flip side, if you're somebody who is kind of electrosensitive and trying to reduce the EMF dosage, then it really behoves these people to just switch off all these devices in the house or put them into wired mode. It's so easy. I mean, every month I go to people's homes and they get me to actually install wired versions, so I can wire up the laptops with a network cable. We can wire up mobile phones, almost everything, the smart TVs, almost everything can be wired up. So there is actually no emissions in the house at all, and this is really the recommended way forward.
Yes, Seth, we've got a question here. I've had clients ask me that the signal power, the actual degree of signal tends to vary on certain days. Does the weather, for instance, or tree cover affect the signal from the phone mast?
Now, that one is quite a key question, and we didn't actually cover that properly in the previous video that we did last week. So I do want to add a little bit about that. So it's quite important to realize that if there is rain or fog or snow, then it just blankets signal levels. I mean, that they drop by, you know, it could be 5 decibels or something. I mean, we're talking like somewhere around a 60–70% drop even if you've got bad weather. Also, if you've got a lot of tree cover, if there's quite a lot of vegetation or trees around, especially buildings, we say that there's this effect from shadowing. And this is where we talk about weather, obstacles, and it's reckoned to be about 3 decibels reduction if you're out in the open, 6 decibels reduction if you've got a lot of trees around or some buildings, and even up to 9 decibels. It's a big difference, and this causes the handsets to actually have to ramp up their power output to compensate for this signal loss. Especially that affects us from the handset point of view, in that if you've got a lot of obstacles or bad weather, the handset is going to be emitting at a higher power, which is going to drain the battery more. And for electrosensitive people, this is obviously worse, because people in the vicinity with a handset will be affecting them more strongly.
That's another factor to consider as well, which we will cover at a later date, Seth, of course.
Okay, so I think we're ready to wrap up for today.
Yeah, I think this is Seth and Geoff signing off, and we'll be back later again with another EMF video.
Yeah, watch this space. Please leave a like, do subscribe, lots more videos on the way. So goodbye from Seth and Geoff.
Goodbye.